So, hi.
Oh, put your hands together for my friend Scott Hanselman. You really want me to stay here?
Stay for a little bit.
All
Just
right,
tell
I'll
me it's
stay
going to be okay. And do they just keep showing our good friend sponsors, or do they end up putting us up there?
I think we'll rotate off. I don't know which screen
I
you
don't know
want
if they're going
rotated.
to put. Let's put my screen up here for a second.
The GitHub screen.
Well, this one here.
There you go.
Hello. So they called me a boomer on the internet yesterday. And it got real personal, and I ended up putting the video private. And there's a new thing out in the internet right now that's called ChatGPT. While you were at this conference, you were all replaced. This is my reaction cam. So I'm just going to say stuff, and I'm going to go. And then our friends backstage will turn that into GIFs, and those GIFs will become NFTs, and then we'll sell them to you.
There you go.
No, they call me a boomer.
This is a different kind of bored chimp right here.
It is, yeah. It is. I'm a bored chimp at this point right now. They call me a boomer because I said that there's value in learning to drive a stick shift, and that maybe the AI doesn't actually know what it's doing, and that maybe the AI was trained on the last 20 years of my blog and Stack Overflow, and they're like, Stack Overflow is going to go away. And I said, well, then what are you going to train it on? We'll train it on itself. And I was like, I don't know. When I made a copy of a mixtape and then I made a copy of that mixtape, it started to sound a little weird. And they were like, mixtape, boomer. And then at that point, I can't win. And I was like, well, 8-track, Napster, what do you want me to say? There's nothing I can say that's going to cause you to appreciate. So there's an interesting philosophy here going on about how do you, I'm going to say you're now one of us, older, senior, people who've been doing this for 30 years, how do we provide comfort and value to the early in career, to the new people that are coming into this space without gatekeeping, right? And gatekeeping is a bad thing, right? Gatekeeping is trying to imply that if you want to use C#, you want a memory manager. Before you get a memory manager, before you get a garbage collector, you got to suffer. You got to learn
First, you have to write
assembly
your
language.
own.
You love the Power Platform. I love the Power Platform. I guess that's how Power Platform people talk. I don't know what that was. I don't know what that accent was or what that was implying to be. I don't know. You need to learn assembler. I'm not saying that. I'm saying that there's joy in understanding those things. I'm teaching my 17-year-old how to drive so that he should maybe think about drive and stick. Mm-hmm. And then he goes, oh, I get it now. I understand how a clutch works. Now I'll drive an automatic.
Yeah.
But I was being told by the lovely people of the internet who are they're just very welcoming and sweet, all of them, aren't they? That maybe my perspective was old, and it smacked of the 90s when calculators came out that did graphs and stuff. And we, the old people, said, well, you won't always have a calculator in your pocket. You got to be able to do that in your head. And then this freaking pocket supercomputer came out, and now apparently I can ask it questions. And people online are saying, you're going to stream intelligence, like in The Matrix, when he's like, I need to learn how to fly a helicopter. No, I know how to fly a helicopter. Pretty sure that's not how the AI works. So I'm trying to figure out what my place is as a senior person in this space, and I don't know. But I don't want to gatekeep. I want everyone to be excited. I want you to use the tools that are available. However, I think there's a lot of joy in learning some of these technologies. So what I have brought you is a series of fun and exciting demos that ultimately signify nothing. So let's start. Let us start with Hello World, shall we? Right? Because that's where it all starts down. So let's go and say .NET new console. Richard is old. We're going to make a console app here. We're going to go into the Richard is old folder. I want to point out my fancy prompt here that shows me that Richard is in fact old. It shows me you like that. It's built into the prompt, so it must be true.
It must be true.
It shows me the current version of .NET. For some reason, an emoji of a human heart, unclear what that is, and then it shows you my blood sugar in real time with a trend line. I appreciate the chuckles there. People were like, I'm not sure if I'm supposed to laugh at the blood sugar thing. But my blood sugar is as important to me as my Git prompt. So if I go Git init, now I've got .NET, the current Git branch, and my blood sugar. And I had a bunch of tater tots before I got here. So we're all going to get to enjoy the current roller coaster of my blood sugar as it goes up. So that's going to be fun.
I thought, well, you do a little debugging, it'll probably drive it back down.
But back to the fact that you're old.
Yes.
So we'll say .NET run. We'll hit enter. We'll go 1, 1000, 2, 1000, 3, 1000, 4, 1005. And we say, Microsoft sucks. Right? Because there's no other response.
That's the only measurement possible.
There, is that took too long.
Yeah.
That was clearly a problem. We do it again, assuming that it will be faster. We are then disappointed. And then we can go .NET build, which will do some proper compiling. And then we'll go bin, debug, ba-doop, ba-doo. Ooh, richardisold.exe. Maybe if we just run that faster. Boop, ba-doo, ba-doo. People are watching. It's hard to type. Oh, that's fast. Now let's do a load test. Okay, so that's clearly faster. We should ship that immediately.
Good.
Right?
Good to go.
Yeah. So a lot of people who know when they write C# or VB or F# that it is compiling into an intermediate language. It's getting chewed, pre-chewed.
Yes.
If C# is apples,
yes,
and I want apple juice, the intermediate language is pre-digested. It's applesauce.
All right.
And you're shipping this applesauce, and then you're going to take the jitter, the just-in-time compiler, which is going to chew on it, and then it's going to turn it into apple juice. And it's pretty fast. So now we're doing something a little faster. And
Juice does go right through me. It's true.
It does go right through you. Thank you for telling us that, because we all needed to know that. Yeah, not to mention dairy. So I think if we go like this, that'll tell you that it was about 102 milliseconds.
Okay.
So that's pretty fast. That's shiny. But I've got this folder full of a bunch of stuff here, including a Richard is old DLL, which I could type .NET on that, and that works too, which means that the exe was probably a lie. That's a lie. That's where the real work happened. So that's interesting. And then that's always shocking for the the early in career people to understand that your computer is lying to you.
Right.
All the time. Like, it's all lies. But they don't call it lies in school, they call it layering. Right? And then if you're really fancy and you have like an architect title, you'll call it a layer of abstraction.
There you go. Yeah.
Right, which is just lies to make you feel good about yourself. What's inside that is intermediate language. So then that intermediate language isn't yet assembler. It isn't like machine language. It gets turned into assembler as you go and run it. So I was thinking it'd be cool to show you what that looks like. So there's a thing called sharplab.io, which is just scrumptious. And you can go over here and you can say something like int I equals 2 plus 2, and then you can say I plus plus, and then you can say console.write I dot toString. And then on the right-hand side over here, you see like the actual compiled C# that ships, and then you can go like this, see the intermediate language.
That looks like sauce.
Yeah, that's applesauce. But then you can do this. What? Assembly language. You say, wait a second, I thought we forgot about that. I thought we didn't have to think about that anymore. Well, then now you're back in the 80s, right? And you're like, oh yes, my old friend. I recognize you. I have no idea what that does, right? calls into some function. So this is all that low-level stuff. And people care about this because we're in a really interesting time where we're going from x86 to x64 and now ARM devices.
Yeah.
And we want this stuff to work everywhere. The intermediate language here, this intermediate code, is processor non-specific. So here we have a 4-byte wide integer, and we're doing stuff to it, and then we're adding 1 to it, that plus plus. That is not specific to ARM or Intel or anything. It's just intermediate. It's on the way. This is then specific to, in this case, x86, which is different than ARM, which is different than whatever. So that's kind of interesting. And you can explore these things inside of this sharplab.io, which is cool. Now, .NET 7 just came out, and I mentioned that because we are in the .NET 7 folder here. If we go back to GitHub, Richard, we see that we are using a version of .NET 7 that just came out a couple of weeks ago. And .NET 7 includes a number of cool features that we can use. We can say not just .NET build, but we can say .NET publish --OS Windows --architecture. I think it's Win664. This is from memory, which means I'm going to get it wrong. --self-contained. Got it wrong. What did I get wrong, friends? I think I'm supposed to say this.
x86.
It's that. No, it's x64.
Or x64.
Or I can pretend that it's not there and use the defaults.
Defaults work.
No, I can say that that's actually wrong, and I should have read the instructions first. When someone in the room is letting me hang here, you should speak up. What are you doing, Hanselman? This demo's not working. It sounds like there was never a plan. Okay, it worked. Totally meant to do that.
Yeah, smooth.
Smooth. Is it smooth as butter that goes through Richard? All right. Oh, what's this? So here, I got a bunch of other stuff. So I shipped you, Richard.
Down to 4K, I feel good
I've
about
actually
myself.
always shipped you and Carl, which is a reference you're not going to understand, but the young people will. If you ship somebody, like it's like a relationship.
Yes.
Yeah. So there's like fanfic, Richard and Carl fanfic.
There you go.
So we shipped this here, which is the actual Hello World.
Right.
Then what's all of this? Why, my friends, that's .NET itself, a shipped .NET. And that means that I could then copy that onto a USB key, and I could hand it to you, and you could run it, and you wouldn't need .NET on your machine at all, which is cool.
As long as I was an x64 machine.
That's a great point. As long as, thank you for saying that, this is why you add value. As long as you were an x64 machine and running on Windows.
Right.
Right. And I could then say publish Linux or ARM or whatever, and that would work as well. However, though, I'm pretty sure in saying hello world, I did not need system.xml.
Pretty sure.
But it really, really wants me to have that because, all good things come off of XML serialization. Well, .NET 7 is doing some cool stuff in this space. Let's go over here to this wonderful repository that is called Trimmed To Do. Trimmed To Do has this little extension here, this Hello World console. Let's go and look at that script, and I'll show you what's in there. It's going to say run project, and inside of run project is basically a little PowerShell script that tries a lot of different switches. So we're going to say run Hello World console, and then we're going to cross our fingers, and it's going to say a bunch of stuff. It's going to build multiple versions of things. You can see what's going by here.
Yeah.
This was me, remember earlier when I was trying to remember what the right thing was? It'll build a debug build. It'll build a Win10 build. It'll build a this build and a that build. And then look at this. Oh. That's not a JIT. It's an AOT. JIT is just in time, and AOT is ahead of time.
Right.
So that did ahead of time compilation, which is a thing that is interesting. So now, what if I take this path right here, and let's go down there. Oops, let's do, we're going to add some quotes around that. Nope, you jerk. Did I have to go down? I got to go farther down. So I'm going to go down there, probably into source. Nope, still got to go deeper. We must go deeper. Trimmed to do blah, blah, blah. Probably that one. And go into the hello world.console. AI will never be able to move around directories. We'll never be able to teach it because that's the last thing. Let's just watch Scott go into some directories. There we go. So this looks not really awesome.
It's huge.
Right? But what's that?
It says native.
It does say native.
Ooh.
Scandalous. That is hello world. which I'm thinking is good, but that's like
A megabyte.
comma. No, how many commas?
2 commas.
I
just
need an
in
AI
different
to
places than where you
teach
put
me
them.
math. There we go. There you go. That's a megabyte.
It's a megabyte.
So this is where you go, Microsoft sucks again,
Right.
Because it's a megabyte, And then you say, well, I could do hello world in assembler, right? Well, but then you don't get the benefits of .NET. You don't get all the trappings and the things of .NET. But it's super interesting because we've just gone and done an ahead-of-time compilation, and native code is inside there.
Right.
And I only need to give you this folder with that 1 megabyte thing, and now I've got an app.
Not a DLL of Insight.
No, and no one knows that it's .NET. So now we're looking at Go and Rust and C and things like that,
Who also spit out these executables.
which is super interesting. And they put out native executables as well. Now this one, to your point, is a Windows executable, but I could do the same thing and I could make a Linux native executable, which means I could make a cool command line tool, give it to a Linux person, and then it would run on Linux, and they would never know that it was .NET.
There was ever
right?
.NET involved.
Sneak it in there. So that's cool. But then we hear about these microservices, and microservices need to be micro, right? And in order to be micro, they must be smaller than this. So the Trimmed To-Do project, which is something that Damian Edwards works on, has basically walks you through everything from a Hello World app to an HTTP listener to something that is more of a proper web project, all the way down to things like a Postgres database and SQLite that'll go and run a back-end web API service.
Okay.
So I could go and split this screen in half. Let me get my current folder. And then I'm going to go and I'm going to use the Windows terminal, which is a thing I'm a big fan of. And I'm going to press Alt while I click on this PowerShell here. I'm going to go and I'm going to hold down Alt with my left thumb. And I'm going to split the screen in half.
Okay.
Cool. So now we've got over here. And it's complaining that the thing's not wide enough because I'm struggling a little bit here to manage the font size because I want to make sure that people can see, but I also recognize that they probably won't be able to see. And then I'm going to go and say, run this particular application on the back end using SQLite. So I'm spinning up SQLite database. I'm using Entity Framework. We're doing a bunch of stuff here. And then here you see another step we've never seen before. Optimizing assemblies for size. It's going to take that .NET DLL and all of the stuff that hangs off of it, all of the dependencies, it's going to shake it.
Right.
And anything that wasn't being called, it's going to fall off, like shaking a tree. This is called tree trimming.
Right.
So it's tree trimming all of the assemblies that aren't being used. Now here it's making sure it's complaining about the database. I've had this problem before. I can never remember. I'm probably running the wrong one. Is it that one? Let's try that one. It's complaining that the database doesn't exist. Optimizing assembly for size again. So I've got lots of there you go. And now it's talking to the database and talking to that back end and saying, hey, this to do, and it's adding some to-dos, making changes. And that little DLL there lives off over here. We can go look inside and see what it looks like. And we'll see when it opens, come on, computer, that it's really, really small. I think we used that one, and that one.
You sure there's not folders?
Yeah. And it trims out all the stuff that it doesn't need. And I've got, in fact, I'll go to the GitHub and I'll show you a table that will be all of the different sizes and the different choices. So .NET is getting smaller and smaller and smaller, and he'll actually generate this table. So you can run this on your own machine, just go and clone this repository. And unfortunately, it looks like it's stuck within this narrow dealie here. We saw that Hello World console. Look at these choices here. Self-contained, 35 milliseconds. Trimmed, ready to run, meaning chewed up but not completely native.
Right.
But then AOT, 10 milliseconds. So you're getting 3x speed up
Right.
just by making
Well, and your
ahead of time.
size has gone down, too.
So then let's go down to something that we are not yet able to go and do ahead of time compilation. We can't do ahead of time compilation on stuff that uses reflection, but we can compress things and get things pretty nice. So that EF Core SQLite thing that we did before, 100 megs, starts up in about a second.
Right.
We can go all the way down to trimmed, ready to run, double the speed. We took 20 megs off, and then we could zip it up. We have to
Now you have to unpack it,
unpack
so time
it,
goes up a bit.
but now our size is down to 40 megs.
Right.
For an actual legitimate web API, not a toy.
Right.
So this means from a world of things like containers, you can have a lot of density. You don't have to think about .NET as being a thing that's like multiple gigs of emotional, psychic weight, which I think some people feel like that a little bit about .NET.
Well, I feel about that anytime I'm moving gigs around.
Yeah, you're moving gigs around, you're like, that sucks. But look at this, some of these are down. Look at that, trimmed compressed is only 20 megs for a legit
Working framework.
working framework, which is really, really cool. So then I mentioned containers. What kind of damage can we do there? Well, there's Docker, which you can run on Windows using Docker Desktop. But Docker Desktop has some licensing where you need to pay for it if you're a big company, and you might not want to do that. You may also not want to put Docker on your machine because you don't have WSL or the ability to run Docker on your machine, or ultimately it's just going to go to the cloud anywhere.
Right.
Anyway, rather. So what if I could do containers without Docker? Here I'm going to go and say code dot. I'm going to open this up, and we'll take a look inside here. And we've got this .NET build containers right here, which is a new package, which allows one to literally build the result of something like this with, and the result is a container, not a DLL.
Okay, but
Okay.
no Docker.
But no Docker. So you can then push it off into somewhere. So let me get the command line from my notes right here. Okay, let's try this. Again, low expectations, right, friends? So I'm saying publish Linux x64, but then I'm saying publish container. That's my target.
Right.
So look at this. Building image Docker with container without Docker on top of base image, and then it goes and it uses the ASP.NET 7 image. And it pushed that container to a Docker daemon.
Okay.
I don't have Docker on my machine. I can push it up to Azure Container Registry and then fire it up in the cloud and do the things that we've seen like Scott Hunter showed and then orchestrate it. Or I can use a thing called Podman. And Podman is a very clever little thing. Podman, I've got running here. Let's go ahead and run Podman Desktop. It's a Docker alternative. And one of the things that I find very clever that they have done is they've made their command line compatible with Docker.
So if you already know the Docker commands.
So you say Docker images or Docker PS or Docker whatever, you just put Podman in front.
Right.
Or if you're really tricky, you just alias Docker to Podman and it just works. So what that means is I can say Podman images or I can say Docker images, and if it aliases over to Podman, you can see 37 seconds ago, I went and created that ASP.NET application here. I haven't gone and trimmed it and made it small, but you can see that I'm working with Docker very nicely here. And at this point, I could go into Visual Studio, I can press F5, I can debug it, I can do all kinds of stuff, and I don't have any concerns about the Docker licensing.
Right, and you're working within a container now, so easy to port up to the cloud or wherever else you want to put it.
Exactly. And what I'm trying to show you is a little bit of an understanding of all the different layers and all the potential that you have once you start realizing the Lego pieces that are available to you. So, hey, it's interesting that Scott showed us the assembly language stuff.
Right.
What can I do with that when I leave this conference? And why is that interesting? Well, I can go back to my company and I can say, are we compressing our results? Are we shipping .NET, or are we just using whatever .NET's already installed on that machine? Are we going to put this in Linux? And where we put it on Linux, is it going to be in ARM? Is it going to be in x64? Is it going to be the smallest, most effective thing possible?
Fastest version.
Why do I not want to ship all these DLLs? Well, I mean, if I'm not using them, they're not needed.
They're just taking up space.
But there's also security reasons.
Yeah.
If they don't get loaded,
Surface
then
area.
there's less surface area, right? Which is great as well. Another thing that you can do is I pointed out we went and we did an OS Linux Arch x64. That could just as well be ARM.
Okay.
Okay. Now, I'm a big fan of ARM, and I've got a Raspberry Pi here as well. Let me show you that Raspberry Pi. And what I'm going to do is I'm going to take this camera, and I've got this Raspberry Pi right here, and I brought my own I brought my own router. And if you're ever doing a talk like this in Vegas, I encourage you to follow these tips that I'm giving you here. So in order to get all this stuff working, I wanted to have my own network that I could rely upon. So I brought my own router, which then has a little screen that shows you the outgoing IP address and the incoming IP address. And you can see that we have 192.168.180.
Internal.
And then this Docker jumps on that network.
Right.
Okay? And then my computer here is on that same network, which is here, called Hanselman Backup. Now here's the question though. If I started plugging other things into this, not everything can get on this Wi-Fi. I want to have a flat address space.
Right.
But you can't always do that. What if I have a virtual machine up in the cloud?
Yeah.
What if I have a Docker container? That would be behind this.
Yeah.
What if I have a phone or an IoT device? Things start getting a little bit complicated and a little bit messy. So I use a tool called Tailscale. And Tailscale is just a joy. Tailscale is a VPN, except I'm not VPNing into anywhere.
Right.
Like some of us in the audience may VPN back into our house to like look at your doorbell or access your home server. You're VPNing to your Comcast or Ziply Fiber endpoint, and now you're in your house. What Tailscale does is it makes a flat network that's just yours, but it doesn't exist anywhere.
Right.
It's a mesh. So this is my computer at home, my Linux instance on my computer at home. That's the Raspberry Pi. That's this computer right here. My iPad and my iPhone are also just all on the same network. So
They all have a huge array of IPs. Like normally in a VPN network, these would all be
yeah.
in the same subnet.
And I can go nuts and do whatever I want.
Right.
Okay. So this Raspberry Pi over here, I can now go SSH, and I've just I'll do it again. I just SSH'd into Hansel Pi.
That's the Pi that's here.
That's the Pi that's right here. And it doesn't matter that they're on the same network.
Right.
You can actually prove it because it didn't even use a 192.168 to do it.
Right.
Now the reason I'm showing you this, again, is I want to give you tips that you can take back to your work or your home immediately and do something with. So if I were working, for example, and this is a very typical thing, I'm working on the Pi and I want to run an application, it's an ASP.NET microservice, and I want to then call it from my phone.
Right.
What do you typically do? Figure out how to get them on the same network.
Yeah.
But the Pi either can't get on the network or it's in a container on the Pi, so it's behind this router, behind the Pi, behind Docker, and then you have to expose a port and expose a port and expose a port.
Yeah.
Tailscale flattens all of that.
You don't have to deal with it.
Okay? So I am now SSH'd onto the Raspberry Pi. I can prove it to you. Here's the Raspberry Pi. It's got 4 gigs of RAM. It's got 4 processors. It's not this computer here that I'm on. So now we get into the stupid part of the talk. As if the last half an hour wasn't stupid. Oh my God. So now, what could I do here? Well, why not run a ZX Spectrum emulator? The ZX Spectrum is an old computer that people from England used and some people from the US. And this is a great emulator that's written by a Microsoft MVP named Jimmy Engstrom. He's a lovely gentleman.
Great guy.
Great guy. And I'm going to go and I'm going to say Hansel Pi 5040. So I'm hitting, I want to point this out. I'm hitting this URL, hanselpi/5001.
Local network. Yeah.
Local network, but not.
Not. Tailscale's doing
Tailscale's doing that work for me. And then I'm going to load up a stupid video game from 1983, so 40 years ago, and run that. And this is written in C#.
What?
Yes. And all the code is available. Jimmy put all of this on his website. So if you go for ZX Spectrum emulator, this is all running up in the cloud. And this is emulating this 6502, or is it a Z80? I think it's a Z80.
Yeah, Z80.
Processor here. But here's the dumb part. What's doing the work? Is the Raspberry Pi doing the work?
You would think.
You would think, but nay. I say nay. I'm going to go and say developer tools, and then I'm going to go here, and then I'm going to wonder what all these buttons are because I can never remember which one does what, and then I'm going to hit refresh. Oh, here's a useful tip. If you have F12 tools open, a special thing happens where if you right-click on the refresh button, they add new features, which means refresh. No, really, I'm serious. No, for F's sake, just please God, refresh. So you've got 3 options for potentially refreshing. Those light up because I've got
Because you're
F12 tools
then.
open, which is great. This is nice. Look at this. What's happening? Jimmy, madman that he is, wrote this emulator in C#, then compiled it to Blazor, which is .NET again.
Right.
And what is Blazor? It's .NET running in WebAssembly. So remember when I showed you how we have intermediate language
Yes.
that then can go out to ARM or x64 or x86? This is compiling to another intermediate language.
WASM.
It's going to IL, and then the IL is being interpreted by WASM, which is then, so the CLR runs in the context of Blazor.
Inside the browser.
And look, these DLLs, these are the actual DLLs. They're unchanged DLLs. So you can go and ship that. So you may have stuff that you could put and run in the browser. Why not let the computer, do the work? And now I'm running, my Z80 calculator. So think about how stupid this is. I don't even know where the plus button is. But this is a 40-year-old computer running in WebAssembly that was compiled inside of IL, but it's running in the browser. It's not running on the Pi, but the Pi is involved. You can see it gets a little bit messy. But what's cool about it is that so far I haven't done anything that doesn't involve just knowing how networks work and C#. So I'm feeling very kind of
existing set of skills.
Existing set of skills.
Didn't write a single bit of Z80 assembly
I didn't write
all.
any, we didn't even think about any of those things. So I got to do that because I was thinking about how Jimmy does stuff. Now, I think the ZX Spectrum processor, you said it was a Z80? Yep, Zilog Z80. That was not my first computer. My first computer was a Commodore 64. You should think about what your first computer was. Maybe it was a 386 or a 486. Maybe it was a Pentium. I don't know. And then you know how we're always asking ourselves, why is this computer so slow? It's like an 11th gen Pentium, There's a